I am Anil Kumar. Welcome to my series on exponential and logarithmic functions. In this video, we have taken exam review for natural logarithm applications. We'll consider 10 questions in this particular video to cover the topic. These questions are very useful if you are preparing for competitive exams or for GCSE or AP calculus. Let me first share with you the questions. You can see the first 5 questions on this page. Take your time to go through them. These are knowledge-based questions. And then we have few more. These 3 questions, they require communication skills and some technical skills to solve. And then we have the last 2 questions which are based on the graph. So that is the variety which we are going to discuss. And if you do these 10 questions, you should be well prepared for any exam on this particular topic. That's the whole idea. So let's take them one by one. We'll begin with question number 1, which is consider the function y equals to 4 plus ln 5 minus x. Write domain, range, equation of asymptotes, x-intercept and y-intercept for the function. You can always extend this to graph the function also, right? So we are given the function here, which is y equals to 4 plus ln 5 minus x. So let's begin with domain. So if I am looking for domain, we know for logarithmic functions, the argument should be greater than 0, right? So basically, we are looking for 5 minus x to be greater than 0. So that really means that minus of x is greater than minus 5, or x multiplying by negative will also change the sign, is less than 5. So that becomes the domain for the function. So you can write domain as x belongs to real numbers where x is less than 5. Perfect. So that is how you get the first part, the domain. As far as range is concerned, for logarithmic functions, range has no restrictions. So you can always write y belongs to real numbers. Now let's look into the asymptotes, x and y intercepts. So the asymptote clearly is when the argument will be 0, right? So the asymptote we can write down as vertical asymptote in this case which will be at x equals to 5. So left side of this 5 is where the graph is going to be. Let's find the x and y intercepts now. So the x-intercept is a point where y value is 0, right? So y value is 0. So let's substitute 0 here and then find the value of x. So let's do this calculation. If I write 0 for y, let me change this ink. So if I write 0 for y, then I get 0 equals to 4 plus ln 5 minus x. So that gives you minus 4 equals to ln 5 minus x. Now we can take exponential function e. So e to the power of minus 4 will be equal to e to the power of ln 5 minus x, which gives you e to the power of minus 4 is 5 minus x. And so we get the value of x as equal to 5 minus e to the power of minus 4. So that becomes your x-intercept, correct? Now let's find the y-intercept. For y-intercept, x is 0. That means x equals to 0. And in our function, what we get is y equals to 4 plus ln. Substituting 0 for x, we get ln 5. So that becomes the y-intercept, right? Now, if you want to sketch the graph, it will be something like this. We are not sketching a very accurate graph here. We're just giving you an idea of what the graph could be. So we have a vertical asymptote at x equals to 5. Let's say that is your vertical asymptote, and this is x equals to 5. And then the graph is something like this. Correct? So that is the graph for you. We already got the value for x and y intercepts. Those values are known to us. So we can write the y-intercept is this value, and the x-intercept, let me write from here, is 5 minus e to the power of minus 4. That is your x-intercept, correct? So that is how you could also sketch the graph. So I hope that makes sense. Now let us take the second question, which is find the solution of ln 2 plus e to the power of minus x equals to 2, correct to three significant figures. So the question is ln 2 plus e to the power of minus x equals to 2. Now to solve this, we'll take e to the power on both the sides. So we get e to the power of 2, e to the power of 2 plus minus x equals to e square. So that gives us ln and e is inverse of one another. So we get 2 plus e to the power of minus x equals to e square. Now we can take 2 on the other side. So we get e to the power of minus x is equal to e square minus 2. Now again, take natural log ln on both the sides. So we get ln e square minus 2. Let's try to solve this on the right hand side. So now we get e to the power of minus x, so we get minus x here, equals to ln e square minus 2. So let's take the calculator, find out the answer. So we have e square minus 2, which is 5.389, and we'll take natural log of this answer. And what we get here is 1.684. So x will be equal to negative 1.684. We need to write the answer to three significant figures, right? So let's round this. So we get minus 1.68. So that becomes the solution for the given question. Okay. Let's take the next question, which is question number 3. Now we have an equation in E this time. Let's see how to solve this. So let's arrange them with highest power. So we get minus e to the power of 3x plus e to the power of 2x plus e to the power of x equals to 0. We can take e to the power of x as common. So we get e to the power of 2x plus e to the power of x plus 1. Sorry, minus signs will come here. We took minus common outside. So that becomes the equation for us. Now, one of the solutions could be e to the power of x equals to 0, which is not valid, right? So e to the power of x equals to 0 is not valid. So that is not a solution. The other one could be e to the power of 2x minus e to the power of x minus 1 equals to 0. Well, let's substitute this as let's say e to the power of 2x equals to t, for example. So we get a quadratic equation which is t squared minus t minus 1 equals to 0. Let's use the quadratic formula to find the answer. So we get t equals to minus of minus 1, which is this, square root of b squared minus 4ac, and that is minus, so that gives us 4 over 2a, so it is 2. So what we get here is, we also know that t should be greater than 0, right? So we'll take the positive value, which is 1 plus square root of 5 over 2. So that becomes the value of t, which is, let's calculate this answer, 1 plus square root of 5 divided by 2 is equal to, in decimals, 1.618. Now t is e to the power of 2x, which is 1.618. So we can say 2x is equal to ln 1.618. So let's calculate this value. So ln of our answer is 0.4812. We have to write the answer to three significant figures. We'll divide this by 2 now to get the value of x. So dividing by 2, we get 0.2406. So rounding to three significant figures, we get the value of x as 0.241. Okay? So that is going to be the solution for us. So I hope the steps are absolutely clear. So factor and then use quadratic formula to find the answer accurate to three significant figures. The next question here is, isolate the variable m from the equation ln m minus ln 1 plus m equals to n. Now let us take question number 4. It is ln m minus ln 1 plus m equals to n. We can apply the logarithmic rules and write left hand side as ln m over 1 plus m equals to n, now exponential to the power of ln m over 1 plus m equals to e to the power of n, and that will give us m over 1 plus m equals to e to the power of n. So let's cross multiply. Then we get m equals to e to the power of n times 1 plus m, which is m equals to e to the power of n plus m times e to the power of n. We can bring it to the left side. So we get m minus m e to the power of n equals to e to the power of n. Now taking m common, we get 1 minus e to the power of n equals to e to the power of n, or m is equal to e to the power of n over 1 minus e to the power of n. So that is how we can actually isolate m. Perfect. So I hope that makes sense. Okay. Now there are different techniques which we could use to isolate. Now at this stage, if I subtract 1 from both the sides, even then I could isolate it easily. Anyway, this is a good way. Let's now take up the next question, which is question number 5 here. We need to solve an equation, exponential equation. Let's write this equation as e to the power of 6x minus 8 e to the power of 3x plus 7 equals to 0. So let's make a substitution, e to the power of 3x as equal to t. So I prefer to always make this substitution. It's kind of simpler. So that becomes t squared minus 8t plus 7 equals to 0. It's a very simple equation to solve now. So t minus 7 times t minus 1, right, equals to 0. That means t could be equal to 7 or t could be equal to 1. But t is 3 to the power of, e to the power of 3x. So e to the power of 3x is equal to 7 or e to the power of 3x equals to 1. So this part is clear. So that gives you x equals to 0, right? Because this is e to the power of 0. So that is one of your answers. The other one, let's write down on the right side, which is e to the power of 3x equals to 7. So that means if I take ln, e to the power of 3x will be e to the power of 7. So 3x is equal to e to the power of 7. X is e to the power of 7 over 3. So that becomes the second solution. So we have x equals to 0 or we have x equals to e to the power of 7 over 3. Correct? So these are the two solutions for the given equation. Okay. Let's take the next question, which is question number 6. Again, we have an equation. It says, solve the equation 5 to the power of x times e to the power of 3x minus 1 equals to 7, giving answer in this particular form. Okay, so exact form basically. So let's try to see how to solve this one. We have 5 to the power of x times e to the power of 3x minus 1 equals to 7. Now we can actually take log both sides. So if I take log both sides, we get ln 5 to the power of x times e to the power of 3x minus 1 equals to ln 7. So here we can apply the sum rule. So we have ln 5 to the power of x plus ln e to the power of 3x minus 1 equals to ln 7. So that gives you x ln 5 plus this gives you 3x minus 1 equals to ln 7. So we have to isolate x. That is what it means to solve for x. So we have two terms which are with x here. So we'll write this as x ln 5 plus 3. And we'll take this 1 to the right side. So we have ln 7 minus 1. And now we can divide and get our solution. Correct? So we can now write down that x is equal to ln 7 minus 1 over, we have here ln 5 plus 3. So we need to write in that order. So x is minus 1 plus ln 7 over 3 plus ln 5. Correct? So basically what you need to do here is take logarithms both sides, natural log, and then apply the formula for, or the law for addition, product to addition. Combine the x terms and then you can isolate x very easily. So that is how you get your answer. Okay, let's take question number 7. Here is an application question. It says the weight Wt in grams of bacteria in a culture t hours after establishment is given by, the formula is weight is equals to 80 times 2 to the power of 0.2 t. Find the time for the weight of the culture to be increased by 120%. Now the condition is increased by. What does that mean? Right? So let's find what is 120% of 180 and we'll add that quantity. Correct? So that means, that basically means We're starting with 80, and when we increased by 80, it'd be like 1.2 times, correct? So that is what it is going to be. So 12 times 8 is 96. So that is the increase. So this much is added on to. So after increasing, the weight will be how much? So in this case, increased weight will be 80 plus 96, right? Equals to 80 times 2, 0.2 t, because net weight will be now plus 96, correct? So that is important to understand. So the final weight we are looking for is 80 plus the increased weight of 96, right? So this is a critical step. Now we just need to solve for it. We can add 6 and 9 and 8 is 17. We'll divide by 80 will be 2 to the power of 0.2 t. So let's take a natural log on both the sides. So we get ln. You can take base 10 also, right? 176 over 80 equals to 0.2 t of ln 2. And now we can isolate t. So we get, let me write here, 0.2 t equals to ln 176 over 80 divided by ln 2, or t will be equals to ln 176 by 80 divided by 0.2 times ln 2, right? So that gives you the answer. So let's find the solution now. So we have 176 divided by 1 divided by 80, natural log of this, divided by zero point 0.2, and then we'll divide this by ln 2. So we get 5.687. So find the time for the weight of the sculpture to increase by 120%. T is in hours. So we get our answer T as 5.687. You could also write this in hours and minutes, right? So let me write this as 5 hours and 0.687 times 60, which is 41 point something, 41.2. So we can say 41 minutes. Is that clear? So we could actually write this answer in hours and minutes also, as I've done. So the decimal part can be multiplied by 60 to get the minutes. Perfect. The next question here is, an investment of $100 is now worth 140. The interest rate is 7% compounded continuously. About how long has the money been invested? We are also given the continuous growth rate. So we know the formula is A equals to principal amount e to the power of RT, right? So there is the formula. So it says the investment of 100, that is the value of P. So we know P is equals to 100, is worth, the amount is 140. Everything is in dollars. And the interest rate is 7%. So 7 divided by 100, which is 0.07. So we know all these values. We need to find t. So let's substitute. So we get 140 equals to 100 e to the power of 0.07 t. So you can divide by 100. So you get 1.4 equals to e to the power of 0.07 t. Take natural log 1.4 equals to 0.07 t. And so we get the value of t here as equal to natural log of 1.4 divided by 0.07, right? Equals to, let's calculate our answer. We'll use the calculator ln 1.4 divided by 0.07, we get 4.8, right? So we get 4.8 years. Now let us take question number 9. We have a graph here. The question is, the variables x and y satisfy the equation y equals to k x to the power of n, where k and n are constants. The graph of ln y against ln x is a straight line passing through the point 2, 1.01 and 5, 0.26. Find the value of k and n correct to two decimal places. So we have natural log versus natural log graph here. So let's simplify the equation. Rather take log both sides. We'll take natural log. So we get ln k plus n times ln x. So let's rearrange this. So we get ln y equals to n times ln x plus ln k. Now that is a line equation. You could always write this to y equals to n times x plus c. So from here, you can find n as a slope, right? So clearly, what you could say here is that n is the slope, like y equals to mx plus c, right? So you could equate n with the slope. So those are related values. Similarly, you could relate the y-intercept with c to find the value of k. So that is the key. So let's find what slope is first. So we know that n is equal to slope. So let's find slope of the graph. The slope m is equal to, let's write n equals to slope. So we are given the 2 points. We are going to use these points, y2 minus y1, which is 0.26 minus 1.01 divided by 5 minus 2. So let's use the calculator to calculate this answer. We have 0.26 minus 1.01 divided by 3. We get minus 1 over 4 or minus 0.25, correct? So that becomes the slope. So we have the value of n, which is for us equal to minus 0.25. That makes sense. The graph is dropping, so that is okay. Now, to find the value of ln k, we need to find the y-intercept. Now, from the graph, it is looking like 1.5. You could actually pick up this value also and then do the needful. Or let's find the equation of line and the y-intercept. We already have the slope. So we can say y equals to minus 0.25 x plus c, which is the y-intercept. So considering one of these points as 2 and 1.01, we can write this as 1.01 equals to minus 0.25 times 2 is the x value plus c. So from here, the value of c will be 1.01 plus 0.25 times this is 0.5, and that gives you 1.51, which is very close to what we estimated, right? But anyway, this is more accurate. So let's find the answer now. So we can correlate the intercept with ln k. Ln k is 1.51, and this implies that k will be equal to e to the power of 1.51. So let's find what is e to the power of 1.51. So we have e to the power of 1.51, and that is equal to 4.526. Correct to two decimal places, so we get the value of k as equal to 4.53. And we already calculated the value of n as minus 0.25, correct? So that is how this question will be solved. So I hope that makes sense. We are almost at the end now. The last question for us, question number 10. Another graph to work with. This time the question is, the variable x and y satisfy the equation y equals to a e to the power of b x minus 1, where a and b are constants. The graph of ln y against x is a straight line passing through the point 2, 0.6 and 5, 1.35. Find the value of a and b correct to two significant figures. Okay, so let's take ln both sides. So we get ln y equals to ln a plus that gives us b times x minus 1. Now, so bx is there. So let's write ln y equals to bx. And the constant term now will be ln a minus b. So that becomes the constant term for us, which is the y-intercept. So this time, if we equate this to the line y equals to mx, let me write like this, okay, plus c. In that case, the slope is b, right? So we get the slope value as b, right? Now this graph is between ln y and x, and the y-intercept is ln a. Okay, so let's equate the slope first. We have these 2 points, so the slope is b. So b is equal to 0.6 minus 1.35 divided by 2 minus 0, 2 minus 5. Okay, so that gives us 0.6 minus 1.35, and we are going to divide this by 3, and what we get here is 4 over 27. In decimals, it is, let's redo it, 1.35 minus 0.6, and we are dividing this by 3, so we get 1 over 4. This is not correct. Okay, so here also we get the slope of which is 0.25. So we have the point 1.35. So let's do it. 1.35 minus 0.6, and we're going to divide this by 3, and we get 1 over 4 as our slope, which is 0.25. So the value of b is 0.25. Now we can find the equation and then find the y-intercept. So to find the equation, capital Y is equal to the slope, which is 0.25, positive this time, plus c. Using one of these points, just say 2 and 0.6, so we get y value of 0.6 equals to 0.25 times 2 plus c. So the value of c is 0.6 minus 0.5, which is 0.1. So the c is 0.1. Okay. Now, c should be equal to ln a minus b, right? So that is what c is. And we already know what b is. B is 0.25, so that should help. Okay. So c is equal to, so we have ln a minus b equals to 0.1. So ln a and b is 0.25. So minus 0.25 equals to 0.1. So ln a is equal to 0.1 plus 0.25, which is 0.35. Correct. And so we get the value of a from here. We'll take e to the power of, correct? So A is equal to e to the power of 0.35. So let's calculate this answer. E to the power of 0.35, we get e to the power of 0.35, and that is 1.419, let's say 42. Correct to two significant figures, so 1.4. So it is only two significant figures, so we'll write 1.4 as our answer. So A is 1.4. Okay. So we get A as 1.4 and B as 0.25. So that is how we are going to solve this particular question. Perfect. So I hope the steps are absolutely clear. Basically, we were given a function's graph, and this graph was ln y. This was between ln y and x. So it's an exponential equation. So in that exponential equation, we found the gradient. The gradient was equal to b, and then the constant y-intercept was ln a minus b. So that helped to solve the equation. So that is how we are going to actually solve this question. I hope you enjoyed the journey of learning how to solve questions related to natural law. So these were the 10 questions, the first five which we did, and then question 6, 7, and 8, and the last two. I hope the solution has really helped you. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.